Forests are often called the lungs of our planet, but not all forests are the same. Among them, tropical peatswamp forests are some of the most vital ecosystems on Earth. They store enormous amounts of carbon and regulate global climate. Yet today, these forests are vanishing at alarming rates. In Southeast Asia, especially on the island of Borneo, peatswamp forests face serious threats. In just a few decades, fires, land conversion, and expanding agriculture have destroyed over half of these precious habitats. One such place is the Klayas Peninsula in northern Borneo. Over 70% of the peatswamp forest here was lost. The main cause? Fires, often caused by human activity, linked to agriculture, settlements, and roads. In Islam, humans are appointed as Khalifah, guardians of the earth. We are commanded not to spread corruption or destruction on the land. But how can we fulfill this duty when the damage is so vast and complex? This is where modern tools like Geographic Information Systems or GIS and satellite-based remote sensing become powerful allies. These technologies help scientists monitor land cover changes, detect fire-prone zones, and understand how human actions shape the landscape. By using knowledge, data, and technology wisely, we not only protect the environment but also uphold the Islamic principle of stewardship. In this story, we will explore how GIS and remote sensing can guide us in preserving what remains of this sacred forest. From Borneo to Sumatra, deforestation continues to threaten Southeast Asia's most critical forest ecosystems. In Malaysia, over 15,500 square kilometers of Sabah's natural forests have been cleared. More than 20% of the state. Across the border in Sumatra, Indonesia, industrial oil palm plantations have replaced large swaths of tropical rainforests and carbon-rich peatlands. This isn't just a local issue. The rapid expansion of oil palm across the tropics is a global environmental challenge linked to biodiversity loss, climate change, and carbon emissions. To understand what's really happening, researchers are now using real-time satellite sensors Sentinel-1, Sentinel-2, and Landsat-8 to detect forest changes even under persistent cloud cover. These tools reveal the truth from above, because only with clear eyes can we begin to protect what remains. While satellite technology has revolutionized forest monitoring, detecting small-scale or subtle deforestation remains a major challenge. Low-resolution imagery can miss minor changes, like illegal logging, selective tree removal, or clearing along forest edges. These activities often occur near villages, plantations, or in fragmented landscapes, making detection difficult. In the Klayas Peninsula of northern Borneo, over 70% of peatswamp forests were lost in less than 2 decades. However, much of this went unnoticed in real time due to cloud cover, fire haze, and low satellite resolution. A recent study in Malaysia and Indonesia showed that combining Landsat, MODIS, and Sentinel-1 data with a technique called change vector analysis significantly improved detection of even the smallest disturbances. Another major issue is the lack of ground validation. Without reliable field data, many remote sensing outputs remain unverified, leading to underreporting or even false detection. To take meaningful action, we need accurate data. That means improving resolution, integrating multi-sensor imagery, and validating results on the ground. Only then can GIS truly support effective forest protection.
Let's explore 3 genre-based case studies that show how these technologies rival what traditional monitoring often misses. This case study explores the application of remote sensing (RS) and Geographic Information System (GIS) for real-time deforestation detection in Malaysia and Indonesia. The first map presents polar plots generated using Landsat-8, Sentinel-1's VV-VH bands, and Sentinel-2 indicates like B4/B8A and B4/B11. Change vector analysis (CVA) distinguishes forest in green, deforestation in red, cloud cover in blue, and shadows in black. This combination supports accurate large-scale environmental monitoring. The next visual compares forest loss over 2 periods, 17 months in Sabah and 5 months in Sumatra. Multi-sensor data reveal rapid deforestation, demonstrating how quickly landscape changes can occur. The final image shows drone-based verification. Red pixels highlight deforested zones, green and pink indicate forest and bare soil. This high-resolution view improves the reliability of satellite findings. By integrating satellite sensors with drone imagery, this approach delivers a strong, scalable solution for monitoring deforestation in Southeast Asia. This case study focused on human-induced deforestation in the peat swamp forests of northern Borneo using remote sensing and GIS. The first map shows the Kias Peninsula in Sabah based on the spot for HRV1 imaginary from 2003. The left panel outlines the study area's landscape, while the inside provides broader location context within Borneo. Next, land cover classification maps from 1985 to 2003 show clear transition into oil palm, grassland and mangroves. With evidence of fire impact in 2003, this visual captures significant ecosystem changes and anthropogenic pressure. RS and GIS tools enable effective monitoring of spatial transformation, spotting better decisions for land use and conservation. For the last case study, highlights high resolution forest monitoring across Southeast Asia from 2016 to 2021 using Planet NICFI and Sentinel-1 imaginary within a remote sensing and GIS framework. The first visual shows 1,515 validation points across the region, essential for confirming the accuracy of tree cover maps. The next set compares the live tree cover with Planet NICFI imaginary for selected mainland zones. Green areas indicate tree cover, grey shows non-tree zones. This map helps detect both loss and regeneration over time. Another set focuses on maritime Southeast Asia. The comparison between derived maps and imaginary supports monitoring in fragmented and coastal area. The following visual compare from GLC10 with refined Planet NICFI data, revealing shaper forest boundaries and improved alignment with actual land cover. A subsequent comparison includes ESA world cover data, showing clearer outlines of roads, clearings, and plantation edges, often overlooked by coarser datasets. The final image captures small-scale disturbances. Green indicate remaining forests, while light gray marks non-tree areas. This refined time series approach strengthens deforestation tracking and supports sustainable land use across Southeast Asia. Deforestation in Southeast Asia isn't always large-scale or immediate. It's often small, scattered, and slow, making it harder to detect and even harder to address. But through geographic information system and remote sensing, we gain tools that help us see through the noise and into the truth. These technologies enable scientists and decision makers to detect change more accurately, monitoring threats in real time, and map vulnerable ecosystems with clarity. This isn't just data collection, it's a critical step toward conservation planning. For the recommendation, national government should adopt high-resolution GIS and remote sensing platforms to complement global forest monitoring systems, and more localized data collection should be integrated into the conservation policies, especially for areas near human settlements. To sum up, with the right tools and the right vision, we can not only reveal what settlement means, but also restore what been lost and protect what remains. That's all for us. Thank you.